All right, so today we are going to talk about our polynomials and quadratics and work on a little bit of review here for the day. So first thing we want to talk about is how do we talk about polynomials? Well, to classify them, we should know a couple of different things about them. So the degree of a polynomial, first we want to name it in standard form. So remember that's alphabetical and then highest degree. So here I have 7x squared minus 3x minus 4y plus 6. It wouldn't make sense for me to put the minus 4y in front of the minus 3x because x comes before y in the alphabet. Since this is my x squared, that one has to be first. And to name the degree of my polynomial, it's the highest degree given. So this would be squared as my highest degree. So remember that the degree of the polynomial is the highest exponent. And to classify our polynomials, we classify them by saying the degree and then the number of terms. So I've got my quick little chart here that says what degree is with its name. So 0 is a constant. That would be just like my plus 6 up here. A degree of 1 is a linear term, so that's like our x plus 5. This x is linear. That's why we call those linear equations. They made a straight line on our graphs. We talked about those in the past. Our quadratic is what we're focusing on mostly today, and that's with a degree of 2. We call that a quadratic because when we think of like squaring 2, or you have a quad wheel, right? That gives you 4, so 2 squared is 4. For a cubic, it's three-dimensional, so we have a third as our exponent. So instead of 1 or squared, it would be a 3 there for our cubic. Finally, we have our quartic, which is a degree of 4. So instead of our 2, 3, 1, 0, whatever, we'd have a 4. We call that a quartic. For our number of terms, if we have 1 term, that's a monomial. 2 terms, binomial. 3 terms, trinomial. 4 or more is a polynomial. Remember that the key here is the first few letters. Mon means 1, bi means 2, tri means 3, poly means many. So 4 and more would just be many terms. All right, so let's do a couple of examples of classifying some polynomials. I've got 3 examples here for us. The first one, we have x cubed plus 4x minus 5. Well, the first thing we notice is that my highest exponent is 3, so we know that my degree has to be a cubic. So we have a cubic. And then we have 1, 2, 3 terms. And we said that a 3 term is a trinomial. So we have our name by degree and name by number of terms. For the second example, we have 7x to the 4th. Well, this is just 1 term, and my 1 term has a degree of 4. So we say our degree first. 4 is a quartic. And 1 term is a monomial. So we have a monomial. We have a quartic monomial with 7x to the 4th. Last one here for naming. We have m squared minus n plus 3m plus 5mn minus 5. Now, some of these might be a little bit jumbled up, right? We know that m is supposed to come before n, so this n would really need to go on the back end here where they're after all of the other m variables have been listed. However, in this case, we don't need to worry about that. We need to see what has the highest exponent, which is actually this m here. There is no n that has a higher exponent, and there's no other variables in this expression. So we know that our highest exponent is a 2. We said when we have a 2, that's a quadratic. Last thing we need to do is say the number of terms. Well, there's 1, 2, 3, 4, 5. Remember that even though there's 2 variables in this one, it's still one expression. If I were to plug in a number for m and n, this would all multiply together to give me one number. So we said there's 5 terms in this expression. Well, if there's more than 4, this is a polynomial. All right, so the next part of today, we're going to talk about multiplying polynomials. Specifically, we're looking at multiplying these 2 binomials together. Remember, when we multiply these 2 things together, we don't only multiply one thing from the left to the right, but we multiply everything by everything. The first together, the outsides together, the inside terms, and the last terms. So if I multiply x and x for those first terms, x times x, then I would have x times 1 for my outside terms, so plus always goes in between my different things I'm multiplying together. So x times 1 plus my inside terms, 2 times x, 2 times x, plus the last thing, 2 times 1. Now we can continue to actually simplify this down. If I have x times x, remember my exponent rule tells me 2 variables multiplied together, I add their exponents. So 1 and 1 would give me x to the second. You could also think of that as if I have something times itself, we write it as squared. The next thing is x times 1. Well, anything times 1 is itself, so we would just have x. 2 times x, I can't really simplify that, so that's still just 2x. And 2 times 1, we just said anything times 1 is itself, so that's 2. Final step, we want to make sure that we combine any like terms. So we have x and 2x here. I'm going to combine those 2 things together, and 1x, remember there's a 1 in front of there, plus 2x would give me 3x. So my final answer would be x squared plus 3x plus 2. So when we multiply these 2 binomials, and they're linear binomials, we multiply them together, we get a quadratic trinomial. So let's try a couple more examples. If I have x plus 3 times x minus 3, this is actually a special case. We'll talk about that after we've multiplied it together. So I take my first terms, x times x, x times x. And I'm going to add on x times a negative 3. Remember that negative stays with the 3. So x times negative 3. Then I have my inside terms, 3 times x plus 3 times x. And then my last terms, 3 times a negative 3 plus 3 times negative 3. So now I'm going to simplify these and actually multiply them together now that I've listed them as such. X times x, we said that gives me x squared. X times a negative 3 will give me a negative 3x. So now we don't need this plus sign anymore because the negative sign beats out the plus sign. Then I have 3 times x, so plus 3x. And then I have 3 times negative 3, which would be a negative 9. Again, we don't write the plus there because the negative beats out the plus. So now I'm going to combine like terms, which are going to be the middle 2. So I'll have x squared, and then if I have negative 3x or minus 3x plus 3x, those actually cancel each other out. So this becomes 0x. And as we were talking about with our elimination process and some of our other lessons, if I have 0 of something, I don't need to write it. It's not going to change my equation in any way. So I don't have to worry about a middle term. I jump right over to my minus 9. So my final answer is x squared minus 9. Now you might be thinking, Brunel, you just said that when I take two binomials, multiply them together, I'm always going to get a quadratic trinomial, but this is a quadratic binomial. Yeah, I know what I said. Sometimes there's this special case that we refer to as the difference of squares. Oops, difference, pretend that's an R, of. So you'll notice that these two original expressions said plus 3 and minus 3, and the coefficients on x were both 1. So basically what happens there is, since I'm taking those 3 times x and a negative 3 times x, we call it the difference of squares because we're really multiplying the same thing together, but one of them has a different sign, meaning that our middle term is going to cancel out and we're always going to have minus a perfect square at the end. All right, let's try this next one. This next one here, x plus 4 squared. Now this one seemed to really trip us up during the school year, so let's talk about this a little bit more. This does not mean that I distribute the power of 2 to each thing like we've been distributing over with x plus 2, x plus 1 up here. Our exponents work differently than a regular number does. Our exponents work in a way that means that I am multiplying this thing by itself so many times. 2 tells us that we have x plus 4 times itself once. So we have x plus 4 times x plus 4. We rewrite it out as itself twice multiplied together. So now that I have two binomials, I can actually multiply those using the same methods we've been using. So I'm going to take x times x, and then x times 4. Now I take my second term, 4 times x, and 4 times 4. Well, x times x will give me x squared. X times 4 is 4x. 4 times x is also 4x. And 4 times 4 is 16. All right, I need to combine my like terms, so 4x plus 4x would give me 8x. So I'll have x squared plus 8x plus 16. Now, this is obviously what we would call a perfect square trinomial because we started off by squaring a binomial when we started. One way that some people think of this is actually just having the x squared, then we multiply, or we add on, 2 times each term multiplied together. 4 times x, and then you square that outside term, so 4 squared. Well, if we were to actually do this, we would still get our x squared. 2 times 4 times x, I can multiply the two numbers together to get 8, and then we still have x, and 4 squared is 16. So that's the nice trick to do with our perfect squares. But remember, it's not just distributing the square over, because we would be missing this middle term. One last example. What happens if I have more variables in one of my expressions? Well, we still just multiply it just like we have been. I take x and I multiply it by everything on the other side. So x times x squared plus x times negative 2x plus x times 1. Then I have the second part, 2 times x squared. Then I have 2 times negative 2x, so plus 2 times negative 2x, plus 2 times 1. All right, so we've listed everything out. Now let's multiply all of our things together. If I have x times x squared, remember I'm going to add those exponents together. So I have x to the 1 times x to the second. That becomes x to the third. Plus x times a negative 2x. Well, negative 2 is still going to stay out front, so negative 2. X times x, we just said I'm going to add those exponents together, so that becomes x squared. X times 1, well, that's still just going to be 1x. 2 times x squared will give me a plus 2x squared. Plus 2 times a negative 2x. Well, we multiply those two numbers together. 2 times negative 2 would give me a negative 4, and we still have x. And 2 times 1 is 2. All right, so now I need to combine any like terms that I have. So I notice that I have an x squared here and an x squared here. If I combine these two things together, I have minus 2x squared plus 2x squared. Well, those will cancel each other out, so I now have 0x squared. And then I have my x and my negative 4x. If I combine those two together, that would give me a negative 3x. Because remember, this is just 1x. I don't see any other like terms that I can combine. So this would be x to the third. I don't need to write this x squared because it doesn't change my expression at all. Minus 3x plus 2. So in this case, we still ended up with a trinomial. But sometimes we'll end up with a polynomial if we take a binomial times a trinomial. Now, this has been our lesson on multiplying binomials together and how to classify our polynomials once again. If you need more help with this, please let me know.